Segment is the determining the Van Hoff factor for the freezing point depression. That's the factor that different solvents dissolve either molecularly or into ions. So this is going to determine, we have three substances: sucrose, sodium chloride, calcium chloride. We're going to determine whether the three do change the freezing point depression, and they're all at 1 molal. And that molal is 1 mole of each substance per 1 kilogram of solvent. And we will determine the factor, Van Hoff factor I. So we'll begin with getting our ethanol solution down to -40 so that we can freeze the sucrose and the sodium chloride and the calcium chloride. We get the ethanol down to -40 by adding dry ice, carbon dioxide, and this will take several minutes depending on how quickly you add the carbon dioxide. You want to add it slowly, as if you add it too quickly then some of the ethanol will boil over and go onto the paper towel that I've set here, just in case we do have some boil over. So we'll be back when this gets down to -40. And now it's reached -40 so that it stays cold enough for the next section. So as soon as all the dry ice is gone, put it into our Erlenmeyer flask. And recall from the first part when we did the lauric acid, we melted the lauric acid and then we froze it. Now we need, since the room temperature is colder than 42 degrees, so the lauric acid will freeze, we need something that's colder than 0 to have our water solution of sucrose, sodium chloride, and calcium chloride. So we will pour our ethanol into the Erlenmeyer flask, about 200 mils, and then we'll put our sodium chloride solution in our jacket as we did with the lauric acid. And we start our data logging device, and we will put it in there, and it's going to take a bit of time, and we're going to monitor the temperature of the ethanol solution so that it stays cold enough. And then we have some spare -40 degrees. And we can monitor that. So if it gets too warm, then we can always put more dry ice that I have ready right there. So this is going to take quite a while before it gets down to, it needs to go below 0. As the sodium chloride, as we're all familiar that we put salt on the road in the winter to melt the snow and the ice. And we know that it stays slushy and thawed down to -10 and -20s and all that, depending on how much salt we have. So this is going to take a while, and we'll be back when this gets closer to the freezing point, when we're going to have slush in the cooling jacket. And in the meantime, we'll monitor the temperature, and if we need to add any more ethanol that it's at -40, then we'll replay that and show you what we do to maintain that at -40. The temperature is being recorded every second, or I'm not sure, and you can see that the graph is continually going down to 0, and we'll pick it up when our solution gets a little slushy, and when it gets slushy we'll be stirring it to maintain constant temperature. Notice the frost, so you might want to scrape that so you can see what's happening inside the cooling jacket. So we're reaching about 0, where water freezes typically, but we can see that it's still a liquid, so that the sodium chloride is having an effect on the freezing point. And as soon as I notice some slushy parts, I'm going to start to stir it so that I can keep it at a constant temperature. And then you'll see that when I start stirring it, the temperature will go up a bit, since I'm putting some heat and friction into the solution. I'm just checking to see if there's any crystals forming yet. And if you look at the chart, now that I'm stirring it, you can see that it's gone up a bit. We were at below zero a little bit, or just at zero. And I think I'm going to continue to stir it until it comes back down. Until we get a freezing constant temperature. So you see now that it's going down because I can't keep up with the cooling process. Okay, so you can see that it's slushy right now, and the temperature is fairly constant there on the screen at minus 3.9. And I'll keep stirring it for a few more minutes so that we get a good freezing point. So while I'm stirring it, I'm imparting some energy to keep it thawed, but yet it's still, and eventually my stirring can't keep up with the cooling. So I'm going to go until the 10-minute mark here on the computer. It's another 10 seconds. So that should give us a good freezing point depression. We've got it quite constant there between -3.9 and -4. And we'll stop it there. So there's our slush, and that would be our sodium chloride. So you would record a delta TF of 3.9 or so, because the water freezes at zero, so obviously we've reduced it by 4 degrees. So that would be, so next we can do the calcium chloride and see if there's any difference in terms of the freezing point depression, the delta TF. So we notice that sodium chloride solution freezes at about -4. Now we're going to do the same procedure with the calcium chloride to see if there's any change because of the calcium chloride formula. So again, we'll put our -40 degree ethanol into our Erlenmeyer flask and start recording the temperature. And it's going to be a while as well, like last time, so we'll cut back and forth as the experiment proceeds, and we'll fill you in on the important points. So there was a point there I noticed that we were below zero, so I started stirring it. You can see that it's gone back up, which is expected as I'm adding heat by stirring it, friction, and you can see now it's going back down as a little difficulty keeping it above zero. I'll just continue stirring until we get a slush point and slushiness. So we have some slush beginning here, and we're down to -4.3. So we'll keep stirring it, and we'll go the length of the 10 minutes as we did for the sodium chloride. So we've reached our run of 10 minutes, so I shut it off, and we'll do glucose next. Okay, for this segment, we'll be doing sucrose. So again, the procedure is identical to the other two. We'll pour our cold ethanol, put our cooling jackets, and then start our computer. And as usual, we'll wait a few minutes as it gets down to zero, and then when we get slush point, we'll start stirring it as we did before. So we're going We're getting below 0 here, and we're going to start stirring it, and as soon as I start stirring, it's gone quite back up. But knowing that it's been below 0, we know we'll be back there in a few minutes. So again, we'll let it run for the 10 minutes as we did the other two. And this is sucrose, by the way, if I didn't mention it before. And we'll see what the difference is in the reduction of the freezing points because of the different substances. Okay, so it's begun to get slushy, and so we're going to keep stirring it and get to a constant temperature as we did before with the other two solutions. Okay, so we're just coming down the last 40 or 50 seconds as we did the other runs, and it looks pretty steady at about negative 2.5 for the sucrose. And we'll collect data and analyze the data and see if there's any difference amongst the three solutions. So right now we're exporting the data so that you'll be able to generate this graph at home and then hand it in as part of your reports.